Hi, welcome to Digital Electronic. Today I'm going to cover 5.6 on JK flip-flop. JK flip-flop is another useful flip-flop, and this is the most one of the most common used flip-flop other than SC. So why there is some difference between SC flip-flop and JK flip-flop? In the JK flip-flop, you're going to have a similar inputs. You're going to have a J, you have a K. So previously we have S, we have C, but now we change to J and K, and we have also clock. So you're going to have a clock. So this is common, but the output also Q and Q bar. Okay, this is since I don't want you to confuse you yet. This is first we're going to cover the synchronous JK flip-flop first. So only five inputs over here, for only three inputs here. Later I will cover another extra two inputs that in other part of the discussion. So only three inputs first. So J, K, and clock. So you're going to have some advantage of J and K, JK flip-flop other than SC. This SC, you have a situation in this truth table. This is truth table SC flip-flop. In the SC flip-flop, you have when you are 0 0 is a whole, 0 1 is clear, 1 0 is set, but in your 1 1 is going to be invalid. So in this particular invalid, it shows that in the four choices there is one you cannot use. So that's why in JK, that's why we come up with this JK flip flop, which you can use all the output accordingly. So this is the normal latch. So you're going to have some modification over here. So this is very normal. This is J, this is K, and this is sorry, this is J, this is K, and this is clock. And the only extra drawing over here is going to be the connection here to here and here to here. So this is the only extra drawing that made this particular JK flip-flop to work as it is. So our mission is to eliminate this particular situation that we have invalid. So this is the symbol of JK flip-flop. We're going to have J, we have K, we have clock, and we have output Q and Q bar. So this is positive, this is negative one. So we're going to have J and K over here. So this is the truth table. So 0 0 is going to hold, 0 1 is clear, 1 0 is set, and 1 1 is toggle. What is mean by toggle is a special situation where whatever you have output at that particular moment, if it is 0, it will change to 1. If if q is equals to 1, it will change to 0. So this is stated over here. So let's see how it works. So please remember the truth table. 0 0 is whole, 0 1 is clear, 1 0 is set, and 1 1 is toggle. And also the clock. So you are going to focus on clock as well. So let's say we have a situation like this. So let's see the example. We are going to have a timing diagram. I fast forward few slides. Please make sure the correct slide. So you're going to have a J, you're going to have a K, you have a clock. So first thing you need to take care is the clock. So let's say the clock is over here, here, and here. So first you need to draw the intervals exactly at this particular. This is second step. So the second step will be the intervals first step is to identify. So this will be your first step. This will be your second step. And then later on, please make sure, try to do the decision based on the truth table. So you're going to have this particular truth table. So over here is 0 0. So you if you are not very confident, you can draw 0 0. This is 0 1 1 0 1 sorry 0 1 1 1 1 1. So 0 0 is a whole situation. So just so that means you're going to have a 0 over here. 0 1 is clear, 1 0 is set, 0 1 is clear, 1 1 is set. Sorry, toggle, it means if this is 0, you're going to change to 1. And 1 1 is also toggle means 0 1 to 0, and then carry on. So then you just need to draw 0 1 0 1 0. So this is how you draw response timing diagram for this one. Okay, now I'm going to introduce another two inputs for JK flip-flop. There is the pre and also the clear. Okay, previously we already mentioned that we have three inputs so far for JK flip-flop. JK flip-flop, you have three inputs. That is your J, you have your K, you're going to have your clock. So you have three inputs. So now we're going to add another two inputs, another additional two inputs. That is the pre and also the clear. In the pre and clear, you're going to have an extra pre and also clear. So in this particular situation, you have another extra two inputs that we call pre and clear. These particular inputs are in an active low. That means it will become active when it is low. So let's say low means when you are giving input of a 0, it will be activated. So right, for example, this one, this is a bar pre. When pre is equals to 0, the output will be 1. And when clear is 0, the output will become 0. This particular situation will help to overrule these two is like a master setup, master reset or master set, where it doesn't care about these two. So this is very additional features. So it's like emergency cut off situation. So when you have an input like this, you are processing normal when pre and clear is not activated. But let's say you activate pre at any particular moment, and suddenly because when you active pre, this will always at 1. But if you are not active if you are not activating the pre, let's say you activate clear, so your output is always be 0. So let's see how it works. Since we're going to have additional pre and clear. So for example like this, so you have a situation like this. So first, when you have a such situation, you let's say you choose to have positive. Let's say you have a positive. Okay, after you done the first step, this is your first step. So second, you need to do the time intervals. The only additional you need to do is you're going to see at pre and clear. So in this particular pre and clear, you're going to have another additional information. This moment, this is when you have a pre and clear. Okay, pre and clear is always inactive by putting at 1 1. This is also 1 1, and this is 0 0 1 1. So when there is a activated, pre is activated, the situation, the output, the final output at this particular moment will according to pre. Since when pre is activated, so let's say you have a 0 here, you have 1 over here, so anything will be just 1 over here. So for clear, when clear is activated, is always 0. So please make sure this one, regardless of this situation, 0 1 you should have set, but and 0 0 you should have whole. So you're going to have a situation, similar situation. So okay, right, let's go for this next step. So this is the step that been chosen. So this is the one we already done. So I this is the one we done. So let's see this example. This is another classic example on how the JK and flip-flop are using the pre and clear. Okay, for this one, you need to go one by one, step by step with me. So first, we understood the clock. So this is the time of the change. You have a J and K, you have a pre and clear. So for pre and clear, please make sure you have, okay, this is the first step. Second step will be this one, step 2, step 1. Third step will be your pre, and then you also have over here. Okay, right. Next, this is your step 3, and you're going to have step 4 is to draw. Okay, let's say we go a little fast so that you can pick up your information over here. Okay, let's go one by one. When you are doing here, let's say when you are especially when you are doing such a situation, always make try to analyze in a situation like this. Okay, try to analyze one by one like this. So when you have a situation like this, first focus on this part. Okay, you're going to have a clock, you're going to have JK. So your J and K is 0 0, your pre is 1 1, and clock over here. So when you have a situation like this, first step is to see what is happening over here. So first you need to see your pre and clear. Pre and clear is not in active mode, so that means good. So now you can focus. Next step is to focus to J and K. J and K is 0 0. 0 0 means whole. So first step is to hold like this, and here is the whole, and you just need to hold as it is. So next, when you are going the next one, next is to see the next step. Before you go to the next step, you see there is a pre over here. Okay, according to the rules, when you have a pre over here, you don't need to see the clock over here. So you just follow there is a pre. So since pre is activated here, so pre is always when pre is activated, the Q will be 1. So when there is activated this from 0 to 1, they will become activated, and that's why your Q is all set over here. Next, going on. Okay. Next, after we go through here, so pre is deactivated again over here. So it become 1 to 0 and become 1 again. So 0 to 1 over here, since this is going from deactivated to activated to deactivated, so the pre is not respond. You just follow here. This is the where you become pre is becoming 1. So you just continue as normal. This one because you need to wait for the second clock over here. So that's why you don't need to wait, just follow the situation step. Over here, the next one is the clock. The next clock is 1 1. So when you have a 1 1 over here, 1 1 is mean toggle. So all the round over here is 1, and now it becomes 0. So you check over here, pre and clear is not activated, so no problem. Next we see and the third cycle. The third cycle is 1 1 1 1 is toggle, so you just need to be toggle here. The next cycle over here is 0 0 0 0 is whole, so you just need to, and your pre and clear is not activated, so no problem, just go through. So whole here is 1 0 1 0 is clear, so eh, 1 0 is set, sorry. So 1 0 is set, so you're going to have 1 0, so that's why you're going to have a set over here. And next is 1 1 1 1 is whole, 1 1 is toggle, so you're going to have a toggle situation. You're going to have a toggle situation. Here is 0 0 0 0 is whole, so just because this is 0, so just hold it. Okay, now here pre is deactivated, so when pre is deactivated, the situation is q1, so we just interrupt without focusing on the clock. So we just interrupt over here. And then this is deactivated over here, so you just need to you don't need to follow because there is no clock, so you cannot change, so they just hold it until the next clock. At this particular thing is 0 0, 0 0 means hold. So because this is 1, just hold it. So this one is deactivated, become activated. So this one is deactivated at this particular moment. So when Q is activated, Q equals to 0. So this one is become 0. Okay, when the clear is still inactive, the clock is not working. So here 1 0, 1 0 is supposed to have a set, but because clear is activated, it is always maintained as 0. So until here, so clear is not still not activated, so you just follow. Here is clear is is not activated, it's become 0 to 1. So now means we cannot change, we just follow, because we need to wait for the next clock. So just follow. And here is 1 1 1 1 is toggle, so you just need to toggle. So this is your final drawing for JK flip-flop. And this is a very classic way of showing how the JK flip-flop works, and this is very important. So this is how JK flip-flop diagram. So just have a look. So this is the common one. So you have a negative JK response. So don't forget this one. You need to look at this one. So you have J, you have K, pre, clear, and Q. So it also look like this inside, how it looks in. So usually we are using like this arrangement: J, K, and clock on the left, pre at the top, clear at the bottom, and Q and Q bar over here. So usually we use this one all the time. So please make sure your clock, when you have like this, is a positive. When you have this one is negative. So this is IC, how JK flip-flop IC. So you're going to have this one, you have two JK flip-flop in one IC. Right, thank you. You can follow the next D flip-flop.